Hello and welcome to Microsoft Hates Greg. My name is Greg Deckler, and today we're going to be talking about complexity. So we've been kind of in between the performance analyzer videos and stuff. I've been talking about star versus flat schemas, and I introduced the concept of complexity a few videos back when talking about World War II logistics and supply lines. So today I want to give you an actual real example of complexity versus simplicity in Power BI and how complexity has a tendency to beget even more complexity. And I'm going to show it with a very simple example. So what I have here over here is I have my flat table, right? It's just a table. That's all it is. It's the entire data model. And over here I have my star schema, right? So, dim customer, dim product, dim date, dim sales territory, fact internet sales 100,000. And, don't worry about this table down here. We'll get to this guy in a little bit. And so I want to show you what happens when I have two slicers on this page, right? I have a color slicer and I have the title, right? And if I click on misses, right, there's only black, blue, and NA because those are the only products, the colors that anyone with a title of misses has bought, right, in the data set. Versus if I do it on the star schema, right, misses, this doesn't change. They're still all here. And I can choose red and it's empty, right? So the reason why this happens is because of these you know, single direction relationships, right? So if I because dim customer and dim product, they don't filter each other, right? Because this filters the fact, this filters the fact, but dim customer does not propagate the filters back to dim product and vice versa, right? And so that's why you get this behavior where, this is not being synchronized essentially, quote unquote, with this slicer down here. Now you're probably saying, well, Greg, the fix for that is really simple, right? We would just take and make this relationship, and we could make all these relationships bidirectional, and they would all work. Except, no, you're not supposed to do that, according to SQL BI, right? And in well, we'll get to this in a second. So what they argue here in a SQL BI is that they have their data model and they show the same kind of thing with the slicers and oops, it's not working correctly. And they say, oh, you could fix it with a bidirectional relationship, but don't do that because you can introduce ambiguity into your data model, into your semantic model, right? So if we put in this bidirectional filter here, now date table has a path to purchases and also has a path to purchases over here. But what they don't point out anywhere in this article, which it just the more I go back and read through the SQL BI stuff, the more just it's either just incredibly shoddy work or it's intentionally misleading. I don't know what how else to like I don't know how else to describe it, right? Because in throughout this entire article, what they don't point out is that this is a multi-fact schema, okay? And you can't introduce ambiguity by putting in bidirectional relationships between tables in a single fact table star schema. Nowhere do they point that out, right? They don't point out that this is only applies to multiple fact table semantic models that share dimensions. That is what this applied to. But they throw the entire thing under the they throw like at the end of the article, they're actually saying don't enable bidirectional cross-fit relationships in your data models in order to sync slicers up with one another. Even though their argument for why you shouldn't do it doesn't apply one bit to single fact table star schemas, not one bit, right? But they don't point that out. They're just like never do it, right? And I find that incredibly bad advice. Um, and just shoddy, and I don't know what else to describe it. And so what they just recommend instead is to use when this has only been introduced in the last few years, is to introduce measures that filter your slicers. Okay, so visual level filters that filter your slicers. So now, right, on top of all the complexity that you added by creating a star schema versus just having a flat table, right? Now you get to add even more complexity by writing a measure for every single one of your slicers in order to filter it, right? That's crazy, right? It's just complexity adding on top of the complexity, right? And again, I don't know if it's like it's just shoddy work. Like it seems like something obvious you should point out that, hey, this we're only having this problem because we have multiple fact tables, right? It seems like it's such an obvious thing that you should point out, and that you don't have this problem with a single fact table star schema. It seems like how do you even miss it? How do you even miss mentioning that? Right? That's crazy to me. It almost makes me the more I read through this stuff, it's like, is it really? Is it malicious? Like, is it intentional? That it's like, well, I mean, these guys are known for you know being the DAX experts, right? So if the solution doesn't involve DAX, then these guys hate it, I guess. I don't know. um, but it seems like an incredible thing to miss, and not point out. And then the other thing to point out on this is, let me get to it, back to the star schema. It's really difficult to actually create the model that they created up here, which basically forms this multiple pathways where they're all active, right? So the way you have to form this is that, let's say you have the date key. So yeah, this is just a copy of the fact table. That's easy, right? So date key to order date key, right? So do that. Yep, that's done. And then we do sales territory key to sales territory key. Sales territory key, right? There we go. And now we can click on this and we make this both. So now we have the date table can go to the table this way, or it can go this way, right? Because this is now going back to the sales territory. So this path or this path, and they're both active, right? They're both active. But if you already have this relationship in this pathway, right, from dim date to table, and you go up here and you say, and then you form the relationship from date key to order date key, say save, it's not active, right? It's not active. So you see the little dotted lines there? And I haven't tried this, but what if we try to make it active? Will it let us do it? Okay, it did. It let us do it. So, but so yeah, so the everybody always says that, like, you can't have two paths to the same table. Well, sometimes you can. Sometimes you can have two paths to the same table, right? So, and yes, this would be bad. You could end up with some really bizarre behavior if you had this in your semantic model. But if you don't have multiple fact tables in your semantic model, then it's nonsense advice to not use bidirectional filters in order to synchronize your slices up with one another. So anyway, anyway, that's not the point of this video. The point of the video is the simplicity. So basically what you've done is you've added complexity by creating a star schema, and then that begets more complexity because now you have to create a measure, right? Between, to filter out these slicers, right? Which is a problem you never even would run into if you just used a flat table. Simple, right? This is what I mean by, how complexity can breed more complexity, and make things longer, take a longer time to create the reports and the semantic models, and all this complexity is just building up and building up and building up and slowing things down and making things more brittle and more fragile and adding more work to everything that you do, right? Don't do that. Right? Keep it simple, right? So, anyway, simple example of how complexity can create even more complexity. So, that is all I have for this video. Hope you enjoyed it, and I'll see you next time.